Phil Estes. Phil Estes is a distinguished engineer and CTO, container and Linux OS architecture strategy at IBM Watson. I'm not going to go through why are you guys always giving me these massive CVs, right? Speakers kind of, come on stage and they rock on their own. So let's welcome Phil. Phil, the stage is yours. Apparently, containers are growing up. Welcome. Welcome to Athens.
All right, thank you. Thank you very much. Welcome to day 2. Hopefully you had a great day yesterday. And hopefully this morning I can continue with information that's both interesting and maybe valuable to your tech career here in Athens or wherever you're from. I'm going to be talking about containers, but maybe not in the way that you've heard before. I'm not going to spend a whole lot of time describing what Docker is or Kubernetes. Instead, we're going to kind of see as that technology has matured, where else those concepts are showing themselves useful. And we're going to look at serverless and IoT. I'm not going to claim to be an expert there, but obviously IBM and other vendors are getting into those spaces. And so we'll look at that. You've already heard a little bit about me. The only thing I'll add is that for about 4 years I've been very active in open source. So I've been working in the Docker community. So I'm also a Docker captain along with Antonis, who you can either, after this talk, you can either be very excited that he got me here, or you can blame him for bringing me to Athens. So depending on the quality of the talk, you can make that decision later. So very active in the Docker community over the last 4 years, contributing. Also now a maintainer with Containerd, which again, I won't deep dive into that technology, but again, we'll see how that plays into to this discussion as well. So we're here in a place with a lot of history, thousands of years of history. I'm not going to go back that far, but I do want to talk about 2014, and hopefully it'll be clear in a minute why I want to go back to 2014. It doesn't seem that long ago, especially if we're talking about ancient history, but in the container ecosystem, we've started talking about container years, that they're much, much longer, and it seems like an eternity to talk about going back to 2014. So if you can't remember much about 2014, maybe you're into what we call soccer, what you call football. So in Brazil, the World Cup was that year. Maybe you're not as excited about who won. Germany won that year, the World Cup. Maybe you were more interested in the Winter Olympics, which were happening in Sochi that year. Speaking of Russia, and in 2014, the guy on the right was our president. The guy on the left doesn't help us define the year because he's always president of Russia, no matter the year. But I should leave politics alone. Although I will also say 2014 was the year Scotland had a referendum to remain in the UK. And then 2 years later, they wanted to stay in the EU, but because they were part of the UK, they had the Brexit. So I think they're going to vote again. Anyway, hopefully that, at this point you're thinking, wow, this talk is really getting derailed. But I wanted to at least get you back to 2014. And why did I want to do that? Well, in May of that year, I was at a very, very large developer conference in the US. I think there were 4,000 or 4,500 developers in this conference center, all talking about cloud computing, all talking about storage and networking. Does anyone have a guess what that conference might have been, 2014? OpenStack. Anyone heard of OpenStack? Interested in OpenStack? OpenStack was huge in 2014. IBM was very involved in the OpenStack community. I went back and looked. There were 2 talks that mentioned containers at the OpenStack Summit in Atlanta. I actually attended one of them. It was by a former IBMer who mentioned this new thing called Docker. But it was actually in, I'll get the right date, June 9th, 2014, that this blog post appeared on the Docker blog and said, it's here, Docker 1.0. And I don't know if you're a fan of Docker, if you've used Docker, but essentially this started a hype cycle around containers and container technology that effectively has continued through today in many ways, including, I don't know if you've seen a chart like this, but this is from Datadog. They produce a lot of interesting statistical data around the container industry, the container ecosystem. And again, so it shows from 2014 with single-digit adoption of Docker and containers. At this point, they were talking about adoption being up 40% in 2017. But as you can see, the last 3 or 4 years have had just this explosion of interest and excitement around containers, around Docker. And actually, if you're interested in more data, Datadog has now been producing a yearly report. And I think it was just a week ago that their 2018 report came out. So again, that's something you can look at on your own if you're interested. But the question we should be asking ourselves is really why in this 2013, 2014 era did containers explode after Docker came on the scene? And the reason we should really be asking that is that it can't be because container technology was new with Docker. Docker obviously popularized the technology. In many ways, they brought some new capabilities, which we'll look at in a minute. But again, for the sake of a short history lesson, since we're in ancient Athens, let's talk about some ancient container technology. And maybe to kind of help people wake up on a Saturday morning, I'll see who's heard or used of any of these. Who's heard of the Chroot, Syscall, and Unix? So this is going back maybe to the 70s or 80s. I used to have a chart with actual dates next to some of these. But Chroot was kind of maybe the earliest idea about how on a Linux system to make a process feel like it had a different root file system than the host operating system. And again, I won't bore you with a lot of technical details, but that was kind of the first interesting movement toward this idea of having processes separated from other processes on a host. A couple other Unix data points. Solaris had zones and BSD had jails. Has anyone used either of those technologies? Heard of them? I see one or two or three hands. So again, these were actual container technologies well before Docker that existed on various flavors of Unix. This one's kind of cheating, so I'm listing Linux kernel namespaces. If you've ever been to a Docker 101 talk, hopefully someone's told you that these Linux kernel features called namespaces are the way that Docker actually provides the isolation that we think of as a container. But the reason I list them separately is because they existed long before Docker was created. In fact, some of them are at least 10 years old, if not more. And so there's actually multiple kernel features in Linux. I think today there are 6 kernel namespaces: the process, the file system, various other things, the network, the user ID system. All these things can be namespaced, meaning I can create a new namespace, and for that process, whether it's the list of processes that are started, whether it's access to the file systems on the host. These are all separated from the rest from other processes on the system. So again, these are things that you could use to create containers before Docker came on the scene, and it's actually the same technology that Docker uses. Related to that, control groups are the other kind of half of what we use in modern Linux kernel container technology. So you have the namespaces, and control groups are what allow you to isolate how much memory can a process use, how much of the CPU, and other things that can be controlled as far as resources, as far as the Linux operating system is concerned. So again, these are Linux features that Docker uses, but they existed before Docker, and we can even list a few products or projects that were available. Openvz, has anyone ever heard of Openvz? A couple folks. So Openvz, I believe Parallels, the company that makes a nice hypervisor today, you can get it for your Mac. Parallels and Openvz, they had created a container technology on Linux. And then finally, LXC and LXD. Those are still active projects today. Has anyone heard of LXC, LXD? A few more hands. So Canonical, the company that makes Ubuntu, the Linux distribution, they have maintainers that still actively create releases of LXC and LXD. And in fact, the very first versions of Docker used LXC as the way that containers were actually created on your system. So again, hopefully I haven't lost too many people here with a bunch of kind of technical details and names of technologies. But the purpose for going over this list is for us to all be on the same page and recognize that container technology already existed before Docker, before this 2013, 2014 era. So I'm going to give you a couple reasons why I think in 2014, when Docker came on the scene, why it created this huge container craze that hadn't existed, even though we've seen that the technologies it's built on were already there. And the nice thing is that I think this relates pretty well. Who was here for the closing keynote? Venkat, late in the day yesterday, talking about simplicity. I think one of the keys for what Docker created was really this simplified user experience to access what were very complicated Linux technologies. So again, maybe you don't understand all the details of kernel namespaces, all the details about control groups, but you knew that if you played with Docker and you typed Docker run Redis, this magical thing happened and you had a Redis server running on your Linux laptop, on your Linux server, and it just seemed cool because you didn't have to do anything. Somebody had already packaged this Redis server with all its requirements, and then you could type commands like docker ps, and you could see a list of running containers and details about them. You could use simple commands like stop and remove, and all this just seemed natural. It was easy to learn, it was easy to use. Who's actually used Docker for anything? Okay, great. So that's a pretty significant percentage of the room. So again, my first kind of statement is that I think Docker became significantly popular because of this simplified access to process isolation that hadn't been so easy to use in prior technologies that were already available. The second aspect is that they created a new way to package images. And there's two aspects to that. One, they made it really easy to reuse other people's images. So obviously if you've used Docker, you maybe have used the docker pull command, or you've typed docker run, and you've seen your Docker engine has connected to a registry, it's pulled an image, and now it's local on your system, and now it runs the container. So that obviously by default, that's a website called Docker Hub, run by Docker, the company, has thousands and thousands of images, some of them officially maintained, from everything from Ubuntu distro to Redis to MySQL. And all these packages are ready-made and reusable. And the creation of your own container can build on others' work. So who's written a Docker file before? All right, still a healthy percentage of folks in the room. I have an example, very simple Docker file here. I basically declare the starting point. So this from line, I'm saying this image is my starting point. It's something someone already built, in this case, the Ubuntu 16.04 base image. Now I can run commands, so I can add new packages. I can set up environment variables. I can copy files into this container. And then I can set an entry point or a command that when other people run my container, or when I run my container, this is the application that gets started. So again, Dockerfile was, again, I think, designed with simplicity in mind. Again, hearkening back to Venkat's talk, there are many things that people have wanted Dockerfile to be expanded to do over the years, and a lot of those have been resisted, so that the Dockerfile concepts remain fairly simple. And again, that keeps it easy to use, easy to create images, easy to share them with others. And so again, my two statements about Docker's popularity, both the simplicity around using complicated features of Linux, and again, I've in essence left out the fact that you can now run Docker containers on Windows. I'm not an expert there, but obviously Microsoft has spent time to add similar isolation capabilities to the Windows kernel. And so when I say Docker runs on Linux, obviously you can add in that Docker runs on Windows as well. But all these same concepts apply, the simple interface, the simple Docker file. And with these two together, I think that's why we saw this significant rise in the popularity and the accessibility of container technology to a much wider audience than all those technologies we looked at on a previous slide. So what we've seen in the past 3 years has really been this explosion that's gone way beyond Docker the company or Docker the open source project to, we have all kinds of things from Kubernetes, which again is another significantly popular orchestration system. It built on the technology that Docker created. So that's a confusing point because Docker has both been seen as a competitor because of their own Docker Swarm orchestration. So I have their logo in the middle. But Kubernetes was initially built around the Docker engine. And so many of the things you see on this slide are things that took Docker's initial work and Docker's initial creation and built on that. Out of that have come two open source foundations. So the Open Container Initiative and the Cloud Native Computing Foundation. And within those, we've done things like standardized containers so that even if other people outside of the Docker community want to create their own container runtime or their own image registry, we've standardized what a container is. We've standardized what an image is. And so the OCI is a place where all the vendors who care about containers can work together to standardize these concepts. The CNCF is a little bit different. They host the Kubernetes open source project, as well as many other projects, including Containerd, which is a core container runtime that sits underneath Docker. It now can sit underneath Kubernetes, and we'll even see some projects that use it in the serverless and IoT worlds. And then even from that have come container-based distributions of Linux. So who's heard of Rancher? Rancher OS? All right, a few of you, Linux Kit. A few of you have heard of that. That was created by Docker themselves. These are all very interesting projects that came out of this initial innovation to create an easy-to-use way to create and use containers. And if you think this slide has a lot of icons on it, who's heard of the CNCF landscape? Has anyone seen the landscape from the Cloud Native Computing Foundation? Obviously, this whole, what we call the container ecosystem, has exploded with tons and tons of vendors and open source projects and anything to do from storage to networking. And again, we don't have time to delve into all this, but my point is that I don't think, again, this is my opinion, but I don't think without Docker's initial innovation, we'd have this explosion of projects and startups and vendors today covering this landscape. But I really want to focus on, what does this mean for us now? I promised to talk about serverless and IoT. I've spent kind of a long time getting us there. But really what I wanted to give you a flavor for today is that the benefits that we've seen from the simplicity of packaging, from the simplicity of a runtime that's easy to use to expose the features of containerization to many more people, is interesting well beyond the sort of straightforward, what we call cloud native use of containers. And so yes, we still see tons of people getting on board with Kubernetes or Docker Swarm, and they're doing very straightforward things like repackaging their applications in containers. They're deploying clusters of distributed applications. You saw talks yesterday using some of these capabilities. So again, that will continue, but what I wanted to give you a flavor for was that really some of what we've seen come out of this innovation are useful in worlds where people aren't writing Docker files, where they're not sort of using Docker directly or Kubernetes directly. And so we're gonna take a kind of whirlwind tour through some serverless projects and through some IoT platforms, and then hopefully wrap it up with a demo that kind of brings that all together in a visual way. So my first position is that serverless platforms are finding container technology to be a great packaging model for the whole functions as a service space. The first one I'll look at is not a serverless project. And so you might think, well, that's weird. Why would you bring up Cloud Foundry, which is officially platform as a service offering? Well, one of my fellow IBMers has been kind of complaining a little bit that Cloud Foundry has been around for years, long before serverless, and yet Cloud Foundry has some of the same kind of capabilities, maybe in a different way, using a little bit different language than the serverless world. And so actually he has a great blog that was, I think, published this year on the cloudfoundry.org website, which you can look at on your own time. But the interesting thing here is that Cloud Foundry, who's ever used Platform as a Service or Cloud Foundry, Heroku is maybe similar in some ways. You simply say, I have an app, I don't want to worry about packaging the operating system and all its dependencies, I'm just going to push it. And so in the Cloud Foundry world, you can CF push. IBM has been operating as a Cloud Foundry public cloud offering for many years. The interesting thing is that Cloud Foundry for years has been running containers. When your app is actually running within Cloud Foundry, it's running as a container. And when we standardized through the Open Container Initiative the definition of a container, the definition of an image, and we provided runC, which is the binary which actually runs containers, whether you're using Docker or Kubernetes or other container runtimes. All these are using runC, and so the Cloud Foundry team, including my IBM friend here, Jules, from our UK office, they said, hey, why wouldn't Cloud Foundry use what you've already built? And so the Cloud Foundry container runtime started to call runC. And that's what it does today. They're actually moving to containerd because they've written a lot of management code around runc. And so again, the Cloud Foundry team has said, hey, now that you have containerd, which drives runc and does a lot of the management, we can get rid of code and just use containerd. And so again, Cloud Foundry is not pure serverless, but it has a lot of the same concepts. And it's important to know that your Cloud Foundry application in Platform as a Service is packaged and running as a container. And so it's using that technology today. So let's move to some actual serverless functions as a service offerings. Again, the interesting thing is that the ones I'm going to show you are all open source, so you can go check out these on your own time. Openvz was built directly as a response to, hey, functions as a service is great. Why wouldn't we just use a container as the delivery method for your functions? And so a former Docker captain, Alex Ellis, created this project. He showed it off at DockerCon. He kind of won one of these cool hacks awards at DockerCon. And since then has really been building kind of a whole community around Openvz. It's a very popular project on GitHub. And again, because he wanted to show that Docker was a great platform for running serverless functions, he's made it easy for Openvz to be deployed on Docker Swarm or on Kubernetes. And in either case, when you execute a function, it just simply becomes a service in Swarm or Kubernetes, depending on how you've set Openvz. And again, he didn't have to write any code to do this. The technology already available runs your function as a container. In a similar way, Oracle has a project called FN. It's also open source. The gentleman involved, I believe they were acquired. I believe FN came out of the Iron Functions startup, which was acquired by Oracle. But again, you directly read their documentation. Use any Docker container as your function. The only requirement to run FN is a Docker engine. And so again, this is another serverless framework that recognizes the Docker container packaging model, the format, perfect for just putting a bit of code in as your function, package it as a container. And again, their focus is on this deployment simplicity. You want to try out FN. If you have Docker, that's all you need. So again, another interesting project. A project that's a little near and dear to my heart is our Apache Openvz project. So this is an open source project that came out of IBM. It was then contributed to the Apache Foundation. So we had some other interested parties, including Adobe, and IBM said, hey, let's make this an open source project not controlled by IBM. So it was contributed to the Apache Foundation. You can see its GitHub site here. Again, this is a little more involved than FN or Openvz. So the idea with Openvz was, again, functions make sense to be packaged as containers, but if instead of making you, the writer of the function, do that packaging, we do that for you when you submit your code to Openvz. And so if it's Node.js-based function or Swift or some other language that we automatically support, Python, we'll automatically insert that into a container and execute your function based on triggers or rules. And the demo I'm going to show has some Openvz functions so we can kind of see how that works. But again, the execution layer of Openvz, again, is just Docker. So your function becomes a container. It's run inside Docker. The great thing about this is if you don't like the languages we offer in Openvz, which is the basis for our IBM Cloud Functions public cloud offering, you can just create a Docker Hub image. You can put any kind of binary in it, upload it to Docker Hub or an image registry, and say, Openvz, when you start my function, just go run this container image. And so the inputs and outputs from that are your function in and function out for serverless in the Openvz model. Again, it was initially created to use the Docker engine directly. We're now working on moving that to Containerd for some performance reasons. And it's also going to be deployable thanks to some work by Red Hat and IBM and others on top of Kubernetes. So again, you can do it on-prem if you just want to try out Openvz, and now it has the capability for its control plane to be run as Kubernetes services. So that kind of sums up a few serverless platforms that, again, saw the value of Docker, saw the ease of the packaging model, and said, we're going to create a serverless platform that simply uses these capabilities rather than write our own execution layer for functions. Let's switch briefly to IoT platforms. This is kind of interesting because I found out just in the last few days that Resin.io has an Athens connection. So this is a startup that I believe has a part of their company here in Athens. They're focused again in the IoT space, and last year they released a project called Balena. So you can see the GitHub URL here if you want to go read more about it. I'll try and make this brief, but the Docker engine open source project has been put underneath this umbrella called the Moby project in the last year, and that kind of decouples the Docker engine technology from Docker's branding, and that allowed Resin.io to create a variant of the Docker engine called Balena based on the Moby project source code, but allowed them to do some interesting things to focus on the IoT and small device space. They did some really neat work around image update. So again, when you type Docker run, that talks to an image registry. It may pull very large amounts of content, which is not so great for a small device. And so they made some really interesting and unique improvements to the image registry interactions. So they can actually pull just deltas of what changed. They also focused on efficiency for memory use, for disk use, and again, all these things to benefit small devices. They also have a bunch of really great images on Docker Hub. So Resin has sort of this Resin OS base image for IoT. So if you have a Raspberry Pi, they have all kinds of pre-built images that actually are really useful, and I actually used one to create the demo. So again, there's a lot more information you can find out about Resin and what they're doing in the IoT space. But again, this is something that was enabled through Docker's open source project and their improvements to that through their Moby project based Balena engine. The other project is fairly new. I just found out about it recently, but Iot is an IoT device platform that has some similarities with Resin, although it's focused more on the idea of a management platform for a cluster of IoT devices. But it uses Linux Kit, which we've already talked about. Docker created Linux Kit, and they use Containerd as the container runtime. And one of the things they do is they took some of the concepts from Kubernetes, some of the concepts from Docker, and created a simple management interface that's more friendly to devices to actually deploy workloads onto, for example, Raspberry Pis. Again, this is an early project. You can go read more about it on GitHub. There's a small set of contributors. But again, be interesting to see where this goes. And again, a lot of this was enabled by the fact of Docker's technology and container technology. So that's kind of my whirlwind tour through both the serverless space and a few IoT platforms where containers have really enabled the features that they wanted to use without them writing their own platform to do so. And so the natural use of containers and container packaging allowed that. So I'm going to try and combine that a little bit with a demo. I'm going to show that containers are being used all over the place in serverless and IoT without us necessarily having to be involved. Who was here for the talk yesterday that talked about the accelerometers in your mobile device? That was really, really great because now I don't have to explain a lot of those things since a lot of you were there. I'm not going to go into as much detail, but I was trying to find something interesting that would allow us to kind of have a visual cue for things that are happening between serverless functions and a IoT device. I have a Raspberry Pi up here and cell phones, but I'm actually not as courageous as she was. So step one, my IBM colleague Rochelle and I are going to try it ourselves first, just with 2 devices, because hopefully we can get that through the demo. You'll see interesting things happening. And then she'll kind of guide everyone here to join the same application. We'll see how great IBM Cloud is, if it can hold up to all your devices joining. But let's try this first. So we're going to go to a simple cloud-hosted app, and I'm going to switch to a display that hopefully, if everything works, we will start to see some data. And then once we do that, I'm going to name my device. So in the dashboard, hopefully you'll see which is me. And again, what's happening here? Oh, it looks like we're getting some data. So as we shake our phones, data is being uploaded to the cloud. I'm a horrible JavaScript programmer, so I'm using like free tools, chart.js, and it's slightly imperfect. But you can see that data is being generated, and let me check my Raspberry Pi. So we're not getting enough. Okay, there you see some lights show up. So the Raspberry Pi is also reading the same database. It's being generated by the serverless functions, and as the rate of data goes up, it's reading that from the database. Again, it's using this Resin IO base image and a container that's running a simple application. So let's try this out. Let's have more people join. What should happen is as we generate more data, this should fill all the way up green, and then it should actually fill up again in red as the rate really climbs up. So let's, do you want to tell them, actually I need to switch to that slide so they can see where to join.
Yeah, so if everyone wants to go in their browser to join and test this out, go to bit.ly, so it's bit.ly/vx18demo, and then you're going to get a prompt that asks you for your unique identifier, so you could do your name or anything that's unique, and then once you're connected, just like shake your phone or move your phone, and then we should be able to start seeing all of that data come in.
All right, so let's, all right, we're getting a little bit more, starting to climb. And there's a leaderboard. We have 20 devices connected. Can everyone see that? 29 devices. Looks like Rochelle is actually in the lead with the most watts produced. 44, 49, 62. So we've got 3 lights. It seems like you guys can't really shake your phones very well. I guess it is Saturday morning, but 74 devices. So actually, we're still working. And the network actually seems to be keeping up. If you were around yesterday, one of the things that she mentioned, I think we we're struggling, the network's struggling a little bit to keep up with all the, now we have 90 devices connected. All right, that's good. I don't know who SOIK is, but they seem to be either very good or they've hacked their phone to generate more accelerometer data than everyone else. All right, so I think in the interest of time, I know this is way more fun than my talk, but we're going to... Yeah, who's SOIK? Raise your hand. Oh, over here in the corner. He's got the best network connection because he's by the door. All right, very good. And if you'll close that tab or close your browser, that'll save my IBM Cloud bill for this month. My manager will be much happier. All right, so that's interesting, but I didn't really tell you all the things that are happening. So let's walk through this for a few minutes if I still have your attention. You're connecting to a Cloud Foundry application. I could have written that in as a container and deployed it in a Kubernetes-based service. But hey, Cloud Foundry was easy. I had some Node.js code that the IBM Watson's IoT service starter kit provided me to make that simple application. And so, again, containers were running there because I've already told you that Cloud Foundry uses containers to run your application. That Watson IoT service has a nice MQTT-based editor. I mean, an editor where I can set up where the streams of data go from your phone. So I had that dumping into an IBM Message Hub service, which is running Apache Kafka message queues. So again, I got some guidance from people smarter than me that I didn't want to be writing to the database every time your phone generated data. And so that got thrown on a queue, and that triggered some IBM Cloud functions that ran, again, Node.js code as a serverless function that would take bulk set of messages from the queue and write that into an IBM Cloud and NoSQL database. So again, that was done in bulk, so it didn't matter if we had 2 phones connected or 90. That wasn't overloading my database because this was happening based on this trigger. And also I had another action that was running that was just doing a sum of all your energy totals from that cloud and database so that I could show my dashboard graph that was climbing as we generated more energy. I cheated again and wrote the dashboard app as a Cloud Foundry app, Node.js. It was simple. Again, containers were running there. And obviously, as I talked about, the Openvz serverless functions were running in a container. I didn't package them in a container. I just gave Openvz that code, and it ran it for me in a container. And then at the bottom, I have my Raspberry Pi up here. It's running this. It has a Docker engine on it, and it's running this container based on the Resin.io image that had the necessary code to light up the LED lights and to talk to this cloud and database to get the data. So again, containers were used all through this without me really building containers or using Docker or Kubernetes in a traditional way. And hopefully that kind of sums up what I was trying to say from the talk, that containers have really become valuable in many of these spaces, whether we're talking about serverless or IoT. And there's definitely other, who's heard of edge computing? It's kind of this newish area that a lot of people are talking about, moving workloads to the edge. And we're finding that, again, people are interested there in containers because containers provide a great way for this workload portability. And so it'll be interesting to see as containers continue to be interesting both to the traditional sense of Docker and Kubernetes, but also to many other areas. So I'm biased, but I'm saying yes, go containers. Containers are still valuable. I think Docker's innovation, plus, again, the workload portability I mentioned, plus the fact that so many people, I mean, we saw the number of hands in here, the availability of worldwide skills around containers. Most people have learned Docker, they know how to use it, and so it matches up nicely with the kinds of technology we're trying to build, to just simply continue building on these technologies that Docker started. So with that, I want to say thank you. I know maybe we have a few extra minutes, but thank you very much for your attention.
Okay, shall we take some questions? You guys are not thinking about questions before, or while you're, any queries you've had while Phil was presenting. This is a great chance to. Thank you. We have a few minutes before we start the next talk. There we are. George, I'm going to learn everybody's name by the end of today. Right.
So, hello. Do you have a GitHub link to test this code to see how it works or whatever?
Just to make sure, are you asking the best distro for Linux?
Do you have the code for the demo available in GitHub or whatever?
Oh, the demonstration? Yeah, I'm actually, so as usual, I don't know if anyone else does this, but I've already put it all on my own GitHub, but I'm nervous enough about how bad my code is because I just heard John Papa's talk yesterday, so I've got a lot of cleanup to do. No, it's still a private repo, but I'll be making it public after I add a README with some details about how I set it up. But definitely this will be something you can replicate and try out yourself as soon as I get the rest of the content into this GitHub repo. I'll tweet about it. In case you follow me on Twitter, I'll tweet out a link to this. It'll just be called IoT-shake in my GitHub.
Any more questions? Any comments? Anything to add? Okay, well in that case, we'll let Phil, well, thank you very much, Phil, thank you.
Thank you.